So as we move down to the bottom of the page here, now they're going to switch us up and have us find the volume of a cone. It's actually the same formula we used up top, which is why it's in the same section. However, the formula becomes circular specific in that the base here is guaranteed to always be a circle. So instead of saying B, the area of the base, and not knowing what the base is going to be, here, because we know the base is always going to be a circle, instead of just saying B, we're going to say pi r squared, which is the formula for finding the area of a circle. So we have that information that's been changed out, and now we can dump numbers right in and start solving here. So in number 7, we've got two pieces that we need. We need r and we need h. R is the radius of the circular base. Well, if we look at the circle piece here, they've identified clearly that the radius is 4. So I'm going to change r in the formula into a 4. As far as h is the height of the cone, the height from the tippy top to the center of the circular base, and that's this dashed line that you see here marked at 12. And that's all I need. The only other part that's in the formula here that isn't already a number, directly anyway, is pi. But as you know in our calculations here, what we've always done is we've always changed pi into 3.14, so indeed I'm prepared to change pi into 3.14. So let's solve. Formula says I'm going to take a third, multiply that by pi, which is 3.14, multiply that by the radius squared. Well, we've already identified that the radius is 4, and then multiply that by the height, which is 12. Of course, just a little bit of order of operations here. You want to grab that exponent first. You want to do that 4 squared first. 4 squared changes it to 16. You're going to multiply that by the 12 at the end with the 3.14 that's in front of it, which is the 602.88. And then if you want to make the times 1/3 really easy, you can just do dividing by 3, because dividing by 3 and multiplying by 1/3 are the same thing. And when I do that, I get 200.96, and that's going to be feet cubed. As we take a look at number 8, very, very similar layout here. They're not trying to trick us here. They've given us the radius, they've given us the height. We'll dump them into the formula and we'll be good to go. So what's the radius of the circular base? Well, the radius here is marked at 5. So r is 5. And then the other piece of information I need is the height, how tall the whole cone is. Well, as you can see, that's marked here on this dashed line, which is 7.6. So I'm going to plug these numbers into the formula. R and h go in. Again, we're going to change pi into 3.14, so we don't have to think too hard about that. So this is a third times 3.14 times the r number squared, 5 squared, times the height, which is 7.6. So I'm going to go ahead and multiply that together. 5 squared, 5 times 5 is 25. Of course, again, I'm doing order of operations first, powers first. Then I'm going to go grab the 3.14 and the 7.6, which is 596.6. And again, multiplying by 1/3 is the same as dividing by 3. So to get the third in there, I'm just going to divide by 3. And that's 198.86 repeating meters cubed. Of course, the one thing you want to look out for there with the cones is you want to make sure you do have indeed the radius. If they give you all the way across the circle, the diameter, make sure you cut that in half for the radius before you dump that into the formula.